Many functions that occur in science are not described by explicit equations. They are defined by experimental data. The next example shows how to estimate the slope of the tangent line to the graph of such a function. In this example, the flash unit on the camera operates by storing charge on a capacitor and releasing it suddenly when the flash is set off. The data in the table describe the charge Q remaining on the capacitor, measured in microcoulombs at time t. Use the data to draw the graph of this function and estimate the slope of the tangent line at the point where t is equal to 0.04. So we use the data in this table, and then we sketch a curve to approximate the graph of the function. So we have 5 data points here, and we connect the dot and we graph to approximate the graph of this function. Okay. So we want to find the slope of the tangent line at this point. Use a method similar to example 1. We can approximate the slope for this tangent line that passing this point by finding slope of the secant line passing this point and the nearby point. For example, this point and this point. Well, we can calculate for the secant line over here using the x and y coordinate of these 2 points. Okay. Because the coordinate P, this point over here, is 0.04, 67.03. And we also know the coordinate for this point right here. Then we use the slope formula. We calculate the slope, and it turned out to be negative 824.25. It is a negative number, which, as you can see, because this line here is falling from left to right. Similarly, we can pick the point even closer to this point. So this time we're going to pick this point and this point. We can calculate the slope of the secant line passing these 2 points. And we can also pick this point to be the other point close to this point. We can calculate the slope of the secant line also. So we make a table over here. So with this point P, okay, let's label this. So this is a point P, and that is a point that we are looking for over here, point P. We're looking for the slope for the tangent line that passing this point. So we're looking for the slope for the tangent line that passing this point. So what we did is we find a nearby point, say here and here, and we find the slope for the secant line by using the slope formula. And then we can also pick point on this side, and you use those points and using this point to find the slope for the secant line passing this point P and the other point, let's call that R. Okay, so we make a table. So when we pick the other point to be those other point here, we have the slope for the secant line turn out to be those value over here. Now, because this point and this point are the 2 closest points to this point, so when we calculate the slope for the secant line, these 2 values are closest to the slope for the tangent line at the point P. So we take the average of these 2 numbers. So how do we take average? We add them up and divide by 2. So we add up these 2 numbers and we divide by 2. And it is negative 674.75. So we estimate the slope for this tangent line is by taking the average of the 2 secant line, the secant line here and also here. We're taking the average of the 2 secant line here and here, and estimate the slope for that tangent line is about this number. So by this method, we estimate the slope of the tangent line would be about negative 675. Another method is to draw an approximation to the tangent line at P. So over here, we draw an approximation to the tangent line at this point when t equal to 0.04. Okay, so we can make a triangle, this ABC. Okay, now to find the slope for this line, we can use rise over run. So rise here is, well, it is falling, so that's why it's negative. And then the distance from A to B, divide by this distance B to C. So if you go from left to right, so the run here is positive, okay? So this AB over here, you can, looking at the graph here, this is about, say, 80.4, and B here is about, the Y coordinate is about 80.4, and then the Y coordinate for this is about 53.6, and that's how they got those numbers. And then for the X coordinate for C would be 0.06, and then for B is 0.02. So you subtract them, and then this is going to be negative 670. So by using this method, we estimate the slope of the tangent line that passing this point when t equal to 0.04 is about negative 670. So those are the two methods to estimate the slope of the tangent line when t is equal to 0.04.